unit circle out is because these are unit circle questions backwards. When we are evaluating an inverse function, instead of having the angle and getting the value of the trig function, it's opposite. We're going to have the value of the trig function, and we're looking for the angle. So it'll say, like, we'll see what the notation looks like. It'll say the cosine is half in quadrant 1. What's the angle that goes with that? And we'll see the notation for it, and your job is to figure out what angle in quadrant 1 has that specific cosine value. Okay, so those are the kind of questions we're answering in this section, which is why it's helpful to have that unit circle out in front of you. All right, the first couple slides, you are not writing anything down. I will show you what you need to write down. Okay, when we talk about inverse functions, we did these in college algebra. We talked about it had to pass the horizontal line test to be able to be invertible, to find an inverse. If you think about the sine or the cosine, or actually any of our trig functions, they do not pass the horizontal line test. So we have to restrict the domain. We have to say, okay, it's invertible, but only from this number to this number. Is it going to pass the horizontal line test? So those are the values we use. So as far as the sine function goes, we want all the possible values of y that are considered. So somebody decided, okay, this is the interval we're going to use. Sine inverse will be defined between negative pi over 2, which is where we have a low point in the sine graph, and positive pi over 2, where we have a high point in the sine graph. Cosine, we have to use a different interval, because if I use negative pi over 2 to positive pi over 2, it doesn't pass the horizontal line test. So somebody decided, okay, if it's cosine graph, again, I want all my possible values of cosine. Well, I can see those between 0 and pi. And if I only look at that part of the graph, it passes the horizontal line test. So that's where inverse cosine is going to be defined. Inverse tangent. They just use that one period that we used for key points, and it'll pass the horizontal line test. And you could do this for all 6 of the functions. What you want to write down is this, okay? If you know nothing else about inverse functions, you want to know this. So this is what our notation is going to look like for an inverse function. It may also say, instead of the sign with the little -1 next to it, meaning inverse, we saw that before with our inverses in the last class, it might say this instead. Arc sine, arc cosine, arc tangent. That means inverse. Okay, so you might see either of those written. If inverse sine is defined between negative pi over 2 and positive pi over 2, on your unit circle, that's those 2 quadrants, 1 and 4. So that's, I think, the easier thing to remember. Instead of negative pi over 2 to positive pi over 2, it's quadrants 1 and 4, or where we're going to be looking for our answers at. And if inverse cosine is defined between 0 and pi, well, that's just between quadrants 1 and 2, or where we're going to be looking. And you'll see for all of these, it's either 1 and 4 or 1 and 2. Every inverse function is defined in quadrant 1, and then really the only thing you're going to need to remember is it defined in quadrant 4 or quadrant 2. Remember, our goal with these is we are going to be finding the angle that goes with a specific trig value. If we are in quadrant 4, the angle answer you give will be negative, because it's between negative pi over 2 and 0. So we have to be careful when we give those answers. Instead of like 330 degrees, I would say -30 instead. Only in quadrant 4 do we have to worry about that. So if I were going to do this like on a test, like you guys have a test coming up soon, right? I would do this in the corner of my paper. I would know in quadrants 1 and 2 are inverse cosine, its reciprocal, inverse secant, and inverse cotangent. That's where those 3 functions are defined. And quadrants 1 and 4 are the other 3. Inverse sine, its reciprocal, and then the only ones that are weird are tangent and cotangent. Those are the only reciprocal pair that are defined in different quadrants. Okay, so it's like a quick little way to kind of condense all that information. Then we just remember, if it's in quadrant 4, our answer is going to be negative. Everybody got what they need off of here? Okay. Okay, so now the problems. You're going to see these are relatively quick, especially if you know your unit circle. Okay, so the first three, whether we see inverse sine or arc sine, these all mean inverse sine, okay? When you see y equals the inverse sine of -3/2, this means, that you don't have to write this every time, that the sine of some angle theta is -rad3/2. And your job is to find that angle theta. That's what y is here. What is that angle that will give us this sine? And if you look on your unit circle, there's going to be more than one answer. So we also have to remember, okay, there's a restricted domain here. If I'm talking about inverse sine, my answer will only be in quadrant 1 or 4. So that's where I'm going to focus. It's the right side of your unit circle. Okay? Is it going to be in quadrant 1 or 4 if my sine is a negative number? 4. Okay, so now we've narrowed it down further. We know my answer is in quadrant 4. Where in quadrant 4 do you have a sine, which is y coordinates, of -rad3/2? What is it? 300 degrees, okay? But if it's in quadrant 4, we're going to list the negative answer instead. So 300 degrees is equal to how many negative degrees? What could you do with that 300? You could just subtract 360, go back a full rotation. So my angle is either, if you want an answer in degrees, -60 degrees, or in radians, it would be -pi/3. Okay, and Math Excel will ask, for one or the other. It'll just say, give your answer in radians, give your answer in degrees. That's it. That's all we're doing. We're looking for the angle that goes with the value of that trig function, and we're looking in certain locations. Okay, so arc sine of -1. So that means sine of some angle is -1. Again, the sine is a negative number. So what quadrant does it have to be in? 1 or 4? It's going to be in 4. Okay, so where in quadrant 4 do you have a sine, a y coordinate, -1? Where do you see it? 270. What's the negative angle? -90. Or -pi/2. Make sense? Okay. The next one's inverse sine of 3. So that means sine of what angle will give me 3? Okay, well, if I'm in 1 or 4, if my sine is positive, it's got to be quadrant 1. But then we run into an issue, okay? Are any of the values on my unit circle a sine of 3? No, okay? It doesn't mean it's impossible yet. The next thing we want to think about is, what does our sine graph look like? Okay, sine graph, basic sine graph, bounces between what two numbers? -1 and +1, right? So is there any angle that's going to make my sine equal 3? No. The range of answers we can have here that we can plug into an inverse function for sine are just between -1 and +1. Those are the only possible values we're going to get out of a sine function, unless there's a transformation, which there's not. So no solution. Okay. Now, if it was a number like 0.6, that's something that we'll calculate with our calculator a little bit later. That's between -1 and +1. It isn't on our unit circle, but we need a calculator to figure it out. Okay? All right, let's try some more. Inverse cosine of rad2/2. So if you need to write it this way, this means sine of what angle? Theta, that's our y. Or I just said sine. Don't do that. Cosine is rad2/2. What two quadrants is inverse cosine defined in? 1 and 2. Okay? If my cosine is positive, am I in 1 or 2? I'm in quadrant 1. Okay, where in quadrant 1 do you have a cosine of rad2/2? 45 degrees or pi/4. Only if it's in quadrant 4 do we have to worry about giving that negative answer. So we're good. What about inverse cosine of -1/2? If my cosine is a negative number, am I in quadrant 1 or quadrant 2? It's quadrant 2. You're going to notice they pick these quadrants because in one quadrant it's positive and the other quadrant it's negative. So that can help you remember which ones it's defined for also. Where in quadrant 2 do you have a cosine, which are x coordinates, of -1/2? 120. So 120 degrees or 2 pi over 3. Okay, let's do arctangent. So we're trying to figure out tangent of what angle will be 0. Inverse tangent, arctangent is defined in quadrants 1 and 4. If you get 0s or 1s, though, we know those are going to be the ones on the axes, right? That's really where we're going to draw our attention to. Tangent's a little trickier because you have to remember how we calculate it. We're not just going to find that number on there. We got to figure out how do we get that 0. Well, tangent is a y over an x. So you're trying to figure out where in quadrant 4 or 1, so again, on the right side of your unit circle, if I do the y divided by the x, am I going to get 0? Does it matter what the x is? 0 divided by anything is 0, right? So where is my y? 0. Zero. Yeah, that's it. 0 degrees or 0 radians. That's it. Okay. Inverse tangent of rad 3 over 3. So that means tangent of what angle will give me rad 3 over 3? Is this going to be in quadrant 1 or quadrant 4? If my tangent is a positive number. It's going to be in quadrant 1. Is it going to be 45 degrees? For sure not, right? We can eliminate that guy pretty quick, because if I do rad 2 over 2 divided by itself, I'm going to get 1. So I know right now my answer is either 30 or 60. You've got a 50-50 shot. You're trying to figure out which pair, if I do y divided by x, am I going to get rad 3 over 3? Well, the only way I'm going to get rad 3 over 3 is if it looks like this, 1 over rad 3. That was rationalized. And the only way I'm going to get that is if it's a half on top and a rad 3 over 2 on the bottom. Or, again, you know it's either 30 or 60. You could pick one, calculate the tangent, and if it's not that one, it's the other one. Okay? So where does that happen? What angle? 30 degrees. Or radians, pi over 6. Okay? Is this making sense? These are relatively quick problems as long as you know where things are defined for.
Like 0.
Uh-huh.
Does it have to be 0 degrees or 0? Could it be 360 or
Could that be a tangent also? Yes, but remember they're restricted to certain intervals, and so when we say quadrant 4 to 1, it's only between negative pi over 2 to positive pi over 2. So only between negative 90 and 90. That also has a tangent of 0, but we only want answers between negative 90 and 90, or between 0 and 180, depending on which quadrants you're defined for. Okay. All right. You guys think you could try these? Maybe? So like this one, secant of what angle is going to give me 2. So figure out what quadrant it's defined in, and then narrow it down from there. Either 1, 4, 1, 2. Here, look at, and see if you can locate it on your unit circle. Okay, so all of these, our answers are actually in quadrant 1. We didn't have any negatives. So a couple of those, like secant, I thought about, all right, well, that's the reciprocal of cosine. So if I flip the number, that's what I'm looking for. And hopefully at this point, since you guys have practiced your unit circle enough, you recognize, right, cosecant and sine, we know those are reciprocals. And this number, that's the reciprocal of rad 3 over 2. That's what we get every time we flip that rad 3 over 2. So that's really kind of what you can be looking for on your circle as you do it. Okay.
I thought the last one would be 120.
It's cosecant. If it's positive, your answer's in quadrant 1. Because over here, that's going to be a negative. Oh, it's okay, so cosecant is only defined in 1 and 4. So yes, that also has a sign of that number, but it's only what quadrant it's defined in. You with me?
Yeah.
Okay. All right, so if it's a positive value of a trig function, it's in quadrant 1. If it's a negative trig function, it's in 4 or 2, and you just have to know which quadrant to look at. You will never get answers in quadrant 3 out of these functions. Make sense? Yeah.
So, guess we're not going to circle this,
You will get a blank unit circle for your test.
but it's not time, so we can still.
It is not time. You're going to get your test like normal, and then you'll get a blank unit circle. And I mean, you could take the first 5 minutes of the test. There's going to be unit circle questions on it, back what we did from like 5-1, 5-2, 5-3. So you can take the first few minutes and fill the whole thing out if you want to.
So like a 2-day test.
It's a 2-day test like normal. Yep.
Or 1 hour each.
Whatever you do on day 1, I will give you that same paper for day 2. So you do not have to do it again. Yeah. Okay. All right, let's do a couple more questions. Let's try these ones now. Okay, find the exact value of inverse sine of pi over 4. Okay, so these are what we call composite inverse functions. One inside the other. So if you guys remember from college algebra, when we did composite functions, you just kind of work from the inside out, especially when there's a number there. So that's all we're doing. I'm going to work from the inside out. Now, when it says sine of pi over 4, that's not an inverse question. It's just a regular unit circle question. Can you tell me what the sine of pi over 4 is? It is rad 2 over 2. So that replaces that bracket. Now we have an inverse function question. Inverse sine is defined in what 2 quadrants? 1 and 4. My sine is a positive number. So is it in quadrant 1 or quadrant 4? Quadrant 1. Where in quadrant 1 do you have a sine of rad 2 over 2? 45 degrees. And if they're giving you a problem in radians, your answer needs to be in radians. So pi over 4. So what do you notice happened there? This inverse sine and the sine canceled each other out. What we started with, we ended with. Okay, let's look at the next one. Inverse cosine of 5 pi over 4. Okay, let's start with cosine of 5 pi over 4. What is it? On your unit circle, that's in quadrant 3, negative rad 2 over 2. Inverse cosine is defined in what 2 quadrants? One and 2. Okay, if it's a negative cosine, am I in quadrant 1 or quadrant 2? 2. Okay, where in quadrant 2 in radians do you have a cosine of negative rad 2 over 2? 3 pi over 4. Did they cancel that time? No. So we can't say that rule is always true. Sometimes it's true. It depends what angle you're given. If I have an angle in quadrant 3, they're never going to cancel because I can't get out an answer in quadrant 3, right? We talked about that. I can only get an answer in quadrant 4 or 1 or 2. So let's try another one. Inverse tangent of negative rad 3. So this time the inverse is on the inside. Okay, so if it's an inverse, we're looking for the angle first now. Inverse tangent is defined in quadrants 1 and 4. If my tangent is a negative number, is it in 1 or 4? It's in 4. Okay, so where in quadrant 4 do you have a tangent, a y over x, of negative rad 3? 5 pi over 3. It would be my, let's see, rad 3 over 2 would have to be on top. Half would be on the bottom. In quadrant 4, my y is negative. So that would be, what did you say, 5 pi over 3? Yeah, that's good. Okay. All right. And now we want the tangent of 5 pi over 3. Don't overthink it. What is it?
Negative rad 3.
Negative rad 3. Okay, so did they cancel there? What I started with, what I ended up with? Yes. Okay, so when in doubt, if you're not sure if they cancel or not, you can just do what we just did here, okay? But there are a couple rules you can remember. They will always cancel if the inverse function is on the inside, like that last one. They will always cancel. If the inverse function is on the inside, they will always cancel. If the inverse function is on the outside, they will only cancel if the angle you're given is in a defined quadrant for that function. So this is the one that I'm like, I don't really even mess with this most of the time. I just kind of evaluate it. I know if the inverse is on the inside, they're going to cancel. If the inverse is on the outside, I just need to evaluate it because it's sometimes going to cancel and sometimes not.
Is there ever gonna be one where they're not the same?
Um,
Sine and one's cosine?
yes, but we don't have to worry about things canceling then. We have another way to evaluate those. You just kind of work from the inside out, right? Like I don't have to have inverse cosine here. I could have inverse sine here.
Okay.
And I know they're not going to cancel, but I would just evaluate from the inside out. I would do this first, and then I would find the inverse sine of that angle. Does that make sense? Okay, good. All right. Last thing I want to do, one more slide, is this guy. Okay, so it's kind of to Sebastian's question. All right, tangent of inverse sine of negative 1/3. All right. So, are they going to cancel? Number one. No, they are not. Is negative 1/3 on my unit circle? No, it is not. Okay, so inverse sine, whatever that is, that's an angle. Yeah? That I'm looking for there? Okay. Can you tell me what quadrant that angle is going to be in? It's either 1 or 4. And because it's a negative, it's in quadrant 4. So I know, just from kind of what I'm given, I have an angle in quadrant 4. So we're going to think back to the beginning of the chapter. If I have an angle in quadrant 4, I can pick some arbitrary point in quadrant 4, and I can draw one of those reference triangles we practiced. Remember, right angle always on the x-axis, hypotenuse intersects the origin. There's that theta, okay? And more than that, I know the sine of that angle is negative 1/3. Sine is what two sides of my triangle? Opposite and hypotenuse. So the opposite is 1, the hypotenuse is 3, and one of those should be negative. Which one makes sense to be negative? The 1 or the 3?
1.
Hypotenuse is never negative. Okay, it's a negative 1 there. Can you figure out what the third side of the triangle is? How do we do that? What's it called? The thing. Pythagorean, yep, okay. So negative 1 squared plus x squared equals 3 squared. So x squared equals 9 minus 1, so 8. So square root of 8 will break down to what? 2 rad 2. And then when you put it in the triangle, just make sure it could be plus or minus. In this case, it would be positive because it goes to the right. Okay, so that picture at this point will allow me to find any function I want. This problem can be simplified to be written as tangent theta. And theta, we drew. And we have everything we need to know about theta. Can you find tangent of theta in that picture? How do you find tangent? Y over x, or opposite over adjacent. So negative 1 over 2 rad 2. If I multiply the top and bottom by rad 2, I get negative rad 2 over, maybe a 4 on the bottom. That's my answer. This you can check in your calculator. Even in a basic calculator, you can type this whole thing in, and the calculator will spit out whatever the decimal approximation of that is, if you want to check it. Yes. We couldn't because negative 1/3 is not on our unit circle. If that was a negative half, I could do all this with my unit circle. So this is only if it's not on the unit circle, only certain values. If it's between negative 1 and 1, it's defined.
Oh, okay.
The function is. Anything above 1 or below negative 1 for our sine and cosine functions is not. Okay, but if it's between those and it's not on our unit circle, we use strategies like this. Or on Monday, I'll show you how you can type some things in the calculator if a decimal would be okay as an answer. Okay, so we've just got like, I don't know, 3 slides left. We'll do those real quick on Monday, and then Monday you guys will have most of the period to work on your math Excel. Okay, and that's the end of the chapter. So then Tuesday, Wednesday next week, we'll do test review. Thursday, oh no, I take that back. we're gonna do review test. So Tuesday we're gonna review, Wednesday test, Thursday we're gonna review for the second half, Friday test. Okay. I'll do cell phone lotto. Circuit trainings due Monday if anybody's interested in that. They're on the cart there. It's a super easy circuit training. It's just like quick properties of functions. Yeah. Oh yeah, I do. Yours was the white one, right? Yes, ma'am. Forgot who I had taken it from. All right, let me stop this.